What's soil permeability? Permeability of soil is how fast liquids can move vertically through the soil. It involves a lot of things about soil. Soil texture, the amount of organic material present, the amount of pore space in the soil. Why is permeability important of soils? For a variety of reasons. Farmers that use different kinds of soils or have to plow in different kinds of soil are interested in permeability because if a soil is very permeable, they're going to have to irrigate a lot more, meaning that there's going to be a lot more movement of irrigation water vertically and down away from their crops. If the soil is not permeable, probably what's going to happen is as they irrigate, their crops might get waterlogged. So we want to make sure that the soil's somewhat permeable and not too permeable. It's got to be just right. The best agricultural crops in the United States are mostly grown in the middle of the country, in what used to be the grasslands. Grasslands have been converted about 95 to 99% into farmlands and into croplands because the soil is so good for growing crops. So it must be just right in the middle part of the country. So another reason that permeability is important, if you're applying any kind of fertilizer or you're spraying pesticides or any pollutants contact surface soil, if it's too permeable, those pesticides, fertilizers, or contaminants can move very far down through the soil into groundwater. And so in areas that heavy amounts of fertilizers are used, if the soil is too permeable or very permeable, it's not unusual to see those nutrients from the surface end up in groundwater. Same thing with pesticides or any other chemicals. Back in the old days when we can just dump chemicals out back in a big hole or in a big pit, it wasn't unusual to have those chemicals migrate vertically through the soil and end up in groundwater. And that's one of the reasons that's totally illegal today in most countries of the world. So let's look at 3 samples and check out the permeability of these samples. And the way that we do this, got sample A, B, and C here. The way that we just check for permeability is basically see how fast water drips through. So I've got the 3 amounts of water, and it's a little bit of a qualitative test in that I'm just going to be timing from the introduction of the water, how long it takes for the water to get into the flask below. So we'll start with the sample on the left, do the sample on the right, and do the sample in the middle. And it'll just give us, it's a basis of comparison. So what you might expect, if soil is very permeable, the faster the drip comes through, the more permeable the soil. Again, the more permeable the soil is, the faster any chemicals from the surface are going to migrate downwards. Another point to be made, as chemicals or water migrates downwards, it can dissolve any kind of nutrients or any kind of chemicals out of the upper layers of the soil and carry it down with it. So we'll start this first sample. We got a little bit of water here. The amount of water is not important. The end point is when the water drips out of the bottom of the funnel into the flask. So I've got a timer here and I'm going to get it going. As soon as I pour the water, I'm going to start my timer. So it's going to take a little bit of doing here. So what I'm going to do is start pouring the water and hit my timer at the same time. Ready? Okay, an end point. Wow, I could barely catch that one. That's about 4.95 seconds before I saw water drip out of the bottom. So that was pretty fast. We'll reset my timer here. Let's go to the sample on the right. Again, the amount of water is not important. The end point, you just keep pouring water until you see some drippage out of the bottom. The end point is when the water hits the flask. Ready? Try this again. Ready, go. And stop. Okay, what we have on this sample over here, the water hit the flask at about 5.97 seconds. This was about 4.9, this is about 5.9, so about a second difference. So far, this sample on the left is more permeable than the sample on the right. Let's try the sample in the middle. I'm going to get a little bit more water, make sure that we have this going. Reset my clock. Are we ready? Sample 3, pouring. Timer's running. Got my funnel filled up. Don't want to overfill it. It's going to flow over. We're already up to almost 20 seconds on this particular sample. The water's migrating down a little bit. You can add some more. But again, you don't want to overtop the funnel. Make sure it's straight up and down here. Keep the water going. So again, if I'm a farmer and I have soil like this and I'm trying to irrigate, I'm going to be really interested to see if I get any percolation vertically through this soil, because right now it's acting like it's holding up the soil migration. You could call it at this point, if you're doing a comparison basis, because the amount of time, it's not calculable as far as like we're going to call this some kind of a soil, like a soil texture or whatnot. This is basically a permeability test. And there we go. Dang, I almost missed it. So that test took 1 minute 37 seconds, and I almost missed it. So what does this tell us about our soil? For one thing, you can see the first soil sample that we did on the left. Note some of the material that kind of filtered out with that particular sample. That's called leaching. And leaching can dissolve mineral matter and or nutrients, pesticides, dangerous chemicals, etc., and carry it downward through the soil. So that's a good lesson there. On our right sample, you can see the water's quite a bit clearer. So not a lot of leaching of materials here. However, there's a lot of materials that can leach through soil that you can't see. So the only way we could definitively tell if there were some chemicals in either one of these is to test it with some further testing equipment. The one in the middle, still, it's just dripping. Dripping, dripping, dripping. Eventually, all that water will drip through there, carrying with it any nutrients or any chemicals. But as you can see, 3 different levels of permeability here. Permeability is related to porosity. We can come back and take a quick look at porosity in another lab.